Hello everyone, welcome to our Interactions Capstone project. In today's video, we're going to introduce you to forces and Newton's laws. How exactly does Newton's laws describe the interactions between objects? This is the essential question that is going to be explored throughout this video. This is a very interesting topic and we hope it will be useful for your understanding. Hope you enjoy and keep watching. To start off, we're going to introduce the different forces known to physics. Applied force is a push or a pull on one object by another that is touching it. An example would be when a person pulls on the door. Gravitational force is an attractive force that exists between all objects that have mass. An example would be when an apple sits on a desk. Normal force is the support force acting perpendicular to the surface. An example is when a person sits on the couch. Frictional force is a force exerted by a surface as an object moves across it or makes an effort to move across it. An example would be when a person walks. Air resistance force is a type of frictional force that acts upon objects as they travel through the air. An example is a parachutist skydiving. Tension force is a force transmitted through a string, rope, or wire. An example is when a person pulls on a rope. Spring force is a force exerted by a spring or elastic material. An example is when a person jumps on a trampoline. When comparing and contrasting mass and weight, we're able to know the various things within their quantities, such as their characteristics, units, how mass and weight changes or not with location. The amount of matter in an object is mass, that is also known as m, is measured in kilograms, while weight, that is the measure of the force of attraction between objects due to gravity, also known as Fg, is measured in newtons. Weight will depend on the gravitation due to gravity, while mass will always remain the same. Some additional facts about mass and weight is that mass is closely related to inertia and can not be measured directly. On the other hand, weight is closely related to gravity and can be measured directly using a scale. An example to compare both would be an astronaut. The mass is the amount of kilogram the person has, so it won't change whether he will be on Earth or on the Moon. On the other hand, his weight changes depending on the acceleration due to gravity, so his weight will be different when he's on Earth and when he's on the Moon. Newton's first law states, an object at rest tends to stay at rest, and an object in motion tends to stay in motion with the same speed and the same direction unless acted upon by unbalanced force. The equation for Newton's first law is net force equals to Fd minus Ft equals 0. An example is an airplane. The forces that are acting upon the airplane is drag and drift. When an airplane is in the air, it is flying at a constant speed. Therefore, the forces drag and drift are equal balance since it is not accelerating or slowing down.
Newton's second law states that for a particular force, the acceleration of an object is directly proportional to the net force and inversely proportional to the mass of the object. The direction of the force is the same as that of the acceleration. The equation would be the net force F equals Fa minus Ff equals ma. The forces that are acting upon the shopping cart is applied and friction force. More force is needed to speed up and push the shopping cart, so the applied force has to be greater than the friction force. Therefore, the forces are not balanced. Newton's third law states that when one object exerts a force on another object, the second object exerts on the first an equal force in opposite direction. Action A on B, reaction B on A. An example would be when a balloon is being deflated, because when the balloon deflates, the air is pushed out of the back of the balloon. Meanwhile, the balloon is also being pushed forward. Balloon pushes up as the air pushes down. The other example would be nail and a hammer. A hammer exerts a force on the nail and drives it into the wall. Meanwhile, there must also be an equal force exerted back on the hammer in the process. While the hammer exerts a force on the nail inwards, the nail exerts a force on the hammer outwards. They are a pair of forces, one acting on the nail and the other acting on the hammer. Thank you for watching, and we hope you enjoyed this video.